Hello, good afternoon, everyone, and welcome to today's webinar. And we are now opening the Zoom room for participant admissions and technical checking. So please kindly wait for the other participant for joining this Zoom. Okay, good afternoon, everyone. And welcome to today's webinar. And we are now opening the Zoom room for participant admissions and technical checking. Please ensure your microphone is mute and your display name includes your full name and institution. We will begin shortly. And should you encounter any issues, please do not hesitate to contact the organizing committee through the Zoom chat. And ladies and gentlemen, our distinguished speakers and participants from across Southeast Asia and Australia, good afternoon and warm greeting to all of you. And welcome to the 13th RIIM Asia Joint Research Program webinar, held in conjunction with the International Nursing and Health Sciences Symposium 2025. Today's theme is Functional Food Innovation and Precision Nutrition for Metabolic Syndrome, Southeast Asian Collaboration Series. And we are truly honored by your presence as we gather virtually to foster collaboration, share scientific knowledge, and explore innovative strategies in addressing one of the most pressing public health challenges in our region. To begin our program, let us open with a prayer. For those who are observing, I kindly invite you to join in your own way as we reflect for a moment. Amen. And next, we invite you all to join us in singing the national anthem of Indonesia, Indonesia Raya, and hymn Universitas Brawijaya. Please rise or place your hand over your heart as a gesture of respect, if you are able.
Blessed
Okay. Thank you. And for the next agenda, to provide a brief overview and background of today's agenda, I would like to invite Mr. Ahmad Hashim Wibisono and as our organizing committee representative to deliver the activity report. For Mr. Hashim, the screen is yours.
Okay, thank you, Tiana. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and very warm welcome to all of you. From the headquarters of the Faculty of Health Science, Universitas Brawijaya, we would like to extend our gratitude and sincere appreciation to everyone who has contributed significantly to the organization of this event. First of all, to the Dean of the Faculty of Health Science, Prof. Dian Handayani, and also all the distinguished expert and invited speakers from University of Wollongong, Australia, also from the Maidol University, Thailand, and also from the University of the Philippines, Los Banos. And finally, last but not least, of course, all of the participants, our fellow practitioners and academics. Welcome to the 2025 International Nursing and Health Science Symposium in conjunction with the 13th RIIM Asia Joint Research Program. This event signifies our commitment to contribute significantly in the strengthening of the continuous development on the academic field of healthcare and also to strengthen the quality of healthcare across Indonesia. We are delighted to host this event and we wish that this will foster further collaboration, exchange of science, knowledge, and technology among the countries in the Southeast Asian region. In this wonderful occasion, I would like to report that the number of the participants, around 170 people, not only from Indonesia, but also from neighboring countries, including Australia, Thailand, Philippines, and also Malaysia. Therefore, it's a great honor for us to be your host. And to everyone, we wish you to have insightful and fruitful experience with the International Nursing and Health Science Symposium. And also, we would like to report that in this year, we will have the International Nursing and Health Science Symposium into 3 webinar series. The first one has been conducted on the July the 1st, and this occasion will be the second. And finally, the third will come on the 29th and 30th September through the platform of the Ministry of Health. Therefore, to all attendants, please put your mark on your agenda and make sure you follow the entire sequence of the conference. And finally, I would like to thank you for all the committee for the efforts and the collaboration. And let's make the Faculty of Health Science as one of the prominent Faculty of Health Science among the faculties in Indonesia. So I think that's all from me and enjoy the symposium. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Hashim. And for the next agenda is now it is my pleasure to introduce the moderator who will guide us through the inspiring sessions. We are honored to be joined by 3 exceptional young scholars and researchers representing 3 countries, the Philippines, Indonesia, and Australia, who bring diverse expertise in the field. Our first moderator is Dr. Yuan Yisi, PhD. He is an associate research fellow at the School of Medical, Indigenous and Health Sciences, University of Wollongong, Australia, and Dr. Shihut, PhD in Health Science and Neuroscience. His PhD research focus on the role of quinolinic acid and neuronal damage and autophagy. And his expertise spans molecular neuroscience, bioinformatics, and brain metabolism. He has published in top journals such as the Journal of Clinical Investigation and Aging Cell, and bring extensive experience in both academic research and biotechnology. We look forward to his guidance in today's discussion. And Dr. Yuan Yishi, are you already here?
Yes, I'm here. Yeah, I'm ready.
Hello, Dr. Yuan Yishi.
Okay, so I start.
Okay, maybe I will introduce the next moderator. The next moderator is Miss Alvina Nur Ishrofi as the RGZ dietitian. She is a registered clinical dietitian with a strong passion for improving public health through nutrition education. She is currently pursuing a master's degree in nutrition science at Universitas Brawijaya, where she is also a UB Star Scholarship Award, and her current research focus on the effect of high fiber foods on metabolic syndrome, exploring aspects such as physical activity, sleep quality, and blood glucose level. Alvina has published several scientific articles, including stunting prevention, food formulation for toddlers, and studies on functional foods and obesity therapy. For Miss Alvina Nur Ishrofi, are you already here?
Hi, Miss Rihanna. I'm here.
Hi, how are you today, Miss Alvina?
I'm very good here.
Yes, I hope you are feeling well today. And thank you, Miss Alvina. And finally, our third moderator is Miss N.C. Cayetano, RND MSc, and she is an assistant professor and division head of the Nutritional Sciences Division at the University of Philippines, Los Banos. Ms. Cayetano holds a Master of Science in Applied Nutrition and has been actively involved in teaching, research, and community extension work. Her expertise spans public health nutrition, food and nutrition education, and toxicological research related to functional foods. We are grateful to have you here. Miss N, are you already here?
Yes, Miss Ariane. Good morning. Good afternoon from the Philippines.
Hello, Miss N. How are you today?
Doing great. It's still raining here. I hope everyone.
Okay, I hope you are feeling well too. And thank you, Miss Anne. And we are grateful to have such a distinguished moderator today. Now I invite our first moderator to take over the session. For Dr. Yuan Yisi, the time is yours.
Okay, thank you. Hi, everyone. So I'm glad to introduce our first speaker, Professor Shifeng Huang. Professor Huang is a distinguished professor at the University of Wollongong, Australia. He is an Australian NHMRC Research Leadership Fellow and the president of the Society of Metabolic Syndrome Control through Nutrients and Lifestyle. He has made pioneering contribution to understanding the neural and pathological mechanism underlying metabolic syndrome, including its links to obesity and behavior regulation. Originally, the announced topic was from beta-glucan to gut microbiota, clinical insights on out-brain intervention for cardiometabolic health. However, to better align with his team's current work, Professor Huang will instead speak on metabolic syndrome control through enhanced dietary fiber. Now I will pass it over to Professor Huang to begin his talk. So we can start.
Hi everyone, my name is Shifeng Huang. I'm a professor in the School for Medical, Indigenous and Health Sciences in the University of Wollongong in Australia. Today we are in this webinar to talk about the dietary fiber in metabolic syndrome control. As we know, metabolic syndrome is a chronic condition. It happens in a very, very high prevalence throughout the East Asia countries. This including obesity, you have lipids problems, glucose problems, hypertension. Put all of them together, I will talk about it in details in my talk. This is a chronic condition. It is actually a risk factor for several life-threatening diseases such as diabetes, cardiovascular disease, and dementia. Now I will start my talk. What is a metabolic syndrome? The metabolic syndrome is a clinical term. It covers 5 main phenomena. Number 1 is obesity. Number 2 is insulin resistance. Number 3 is hypertension. And then triglyceride. The only one here is a good cholesterol is too low. So put 5 phenomena together. There's a cluster of phenomena in the clinic called metabolic syndrome. The diagnosis in the clinical criteria is these 5. Number 1, like I say here, is visceral obesity, or you call it abdominal obesity, because men and women, they are different. Particularly in the measurement here is about the waist circumference for the man, if greater than the 102 centimeters in waist circumference. For women, if greater than 88 centimeters. This is called the visceral obesity. Of course, here you have to add the BMI for the obesity. BMI 25 to 29, and then 30, above 30 is the obesity. Between the 25 and 29 will be the overweight. Then you have triglyceride, which is the bad fat flow in your bloodstream. Is too high, greater than 150 milligram per DL. Then you have the cholesterol. So you have all those detailed diagnosis criteria. Then if a person has fulfilled 3 criteria, for example, obesity, triglyceride, and HDL above the normal level, then we can call it metabolic syndrome. In fact, any of these 3, you could have the blood pressure, triglyceride, obesity. If you have these 3 above the normal condition, is clinically can be diagnosed as a metabolic syndrome. The getting worse one is this person has all 5 outside the normal range. So they have a different degree of metabolic syndrome according to those criteria. Metabolic syndrome has a very clear age related, as this figure shows in INHSS study about the age-specific prevalence of the metabolic syndrome. As you can see here, the younger, the less likely to develop metabolic syndrome. The older, after 50 years of age, you are very much 35%. 60 to 69 age, older, and then you have nearly 45%. Therefore, the age certainly play a role there. In terms of male and female, they are relatively similar. This figure is trying to show you the age play an important role when you do the study. So what are the consequences of metabolic syndrome? As we have said, the metabolic syndrome is a cluster of those phenomena or the clinical symptoms. Then the problem is they can increase the disease happening. Therefore, it's a risk factor. In particular, about the heart disease, is risk for the heart disease. Therefore, the prevention is extremely important here to prevent metabolic syndrome towards the life-threatening diseases. such as type 2 diabetes, hypertension, the dementia, cancer, those problems. You mean these brain problems, and even the various problems here. So we need to prevent them. The next slide I want to demonstrate here is a gut microbiome play a very important role in the metabolic syndrome. When you see it in the chronic conditions, for example, person with obesity, compared with the person do not have obesity, when you look at the gut microbiome, they are very different in terms of the diversity, the richness, and even the species can vary significantly in terms of amount and even the species. Then this figure trying to demonstrate that if you do an animal study using mice, you take the gut microbiome from obese person to put into a mice, normal mice, they become obese. If you take the lean person, take their microbiome, put that into the mice, same strain of mice, they do not become obese. Therefore, this indicates this microbiome differences play a critical role in terms of obesity and metabolic syndrome. This will link to our next topic about why dietary fiber is important, because when we eat dietary fiber, the human like us, we cannot use those fiber, but our gut microbiome, they will use this fiber to produce, for example, short-chain fatty acids and some proteins. They are beneficial to the human. Therefore, we are going to introduce that dietary fiber in next few slides. Why dietary fiber is so important? Are they all important in terms of different type of dietary fiber? That's the topic we're going to discuss here. So why dietary fiber is important? So let's see the human development history. The humans, let's say that very early, many years ago, 200,000 years ago, at BCE time, we call it Homo sapiens. They are really hunting for the food, whatever they can get. Then gradually, now we come to the hunting era. So there we eat a lot of the meat through the hunting, and we also have some fruit. Then later on, we really started to culture the wheats, the rice, etc. This really only for the last couple hundred years, the food chain for the humans has major changes. For example, we have now a lot of sweet drinks like a Coca-Cola. It's first invented in 1886, about 130 years ago. Like McDonald's, those refined food, take away those dietary fiber, for example, from the wheats, from many things. You eat a lot of McDonald's. That's all refined food without, it's really low dietary fiber. Now people start to recognize dietary fiber is important. But compared to the before, we have much less dietary fiber in generations. Not only our generation, our parents, grandparents, and even their particularly in the developed countries, the dietary fiber intake significantly reduced. And coincidentally, we can recognize now there is an epidemic or even pandemic obesity has occurred. So metabolic syndrome, for sure, that link to the diet. So less fiber, high energy, high palatable food diet, those all have contributed to obesity, metabolic syndrome. Surely we have other things like sedative behavior, stress also contribute to obesity. Gene also play a role, but unlikely our gene will change much over, for example, 50 years. It's really diet, sedative behavior, and working style and stress. Diet, low fiber, contributes to the metabolic syndrome today. Now here is the meta-analysis and published in a systematic review to look at the dietary fiber intake, how much fiber intake versus mortality, the death. The review paper, although only have done 6 from this particular review, it did demonstrate that you have this RR value 0.77 overall RR value. Therefore, you have something like the beneficial effect if you have a high fiber intake, reduce the mortality rate by 23%. It's quite substantial. Now since dietary fiber is so good, let's talk about the types of dietary fiber. Now dietary fiber can come from the plant cell wall. Actually, that's where they come from. And also can come from inside, but mainly from the cell wall. For example, wheat, oats, etc. It is cellulose or semicellulose, resin, pectin, lignin. So those are the components. If you classify them into the type of fibers, you can have a soluble dietary fiber and insoluble fiber. And the insoluble fiber including the cellulose, lignin, and some semi-fibers. So those fibers will not be able to dissolve in the water, insoluble. The function is to help you to aid the bulk to the stool, help food pass through your gut, GI, gut intestinal tract. So cannot be fermented by bacteria. It's just to help you to form the shape of the stool. In terms of the soluble fiber, it's really the bacteria will need them. Therefore, they are called bacteria accessible fiber. But there are some details we will explain which will be the bacteria accessible fibers. But for now, as an overall concept, it can dissolve in the water. There we can have the fermented in the colon by the bacteria. Also, you can produce those viscous and inside your gut, Then surely when you ferment it, you can produce a gas, then pump out the toxic gas, and they become a prebiotic for bacteria as the food. And after that, then will produce metabolized by the bacteria based on those fermentable dietary fibers. Like we have said, you can produce various short chain fatty acids, the proteins, even the neurotransmitters. And those will help you, one, to provide nutrition for you or for your gut, and also can help you to build your immune system to against the bacteria. There are many functions, even can produce antibacterial proteins through this gut microbiota. All this can lower the risk to a number of diseases like cardiovascular disease, type 2 diabetes. Now today we're going to talk about the cognitive impairment. So there are many beneficial functions from fermented dietary fiber. Now here's the paper. I'm going to focus on a particular type of fiber. It's about the oats fiber. Has a cholesterol lowering effect. This is again another meta-analysis based on close to 20 papers. Now we only look at the overall 25 papers actually, about 1,600 subjects involved in a total 25 studies with a dose of 5 grams a day. Then the overall effect, as you can see here, this can lowering your cholesterol levels. So it's quite a nice study. Cholesterol is bad for your cardiovascular, bad for body metabolism. Now, my group has spent some time to study our beta glucan. Now here's the beta glucan. You can extract beta glucan from oats or from the mushroom. From the structure, they are quite different. The oats, you can have it's a polysaccharide. You can have 1,3,1,4 link. However, if it's a mushroom, you can extract them as well. It's also called beta glucan. But from chemical structure, they are 1,3,1,6 link. You have this branch. Because structure is different, you can have different function. Here we have 2 papers we published recently using the animal models to study the dietary fiber and the cognition. The first one is about the dietary fiber deficiency or fiber deprived diet, see what happened in terms of the gut-brain axis and the regulation of cognitive function. The second paper we have published recently is on the beta glucan attenuates cognitive impairment. So we quickly go through them. This is your first paper. Dietary fiber deficiency induces behavioral changes. Now here you can see this in your control. The mice can make a nice nest. Then if you have fiber deficient diet for 15 weeks, the mice just do not make this nice nest. This is only a representative picture. And here it's over 10 mice that do a statistics, show a significant difference. Another one here you can see this is about a cognitive function related. This is a known object. This is a new object. So the control mice, they want to explore to the new objects, but then if you have fiber deficiency, the exploratory behavior will be significantly decreased. So compared to that, we trying to prove this is through the short chain fatty acids. Now in this case, if we knock out this gene called GPR41 and 43, like we said before, therefore you see this is the effect like deficient fiber diet significantly increased. Similar to the exploratory behavior, you have to knock out these two receptors. So exploratory behavior will be significantly reduced. Conversely, if the fiber deficiency mice, if you provide them with the short chain fatty acids, then you will reverse this behavior. This is the novelty behavior, reverse. Same will have another two behavior test. Therefore, from this study, we have demonstrated that short chain fatty acids is important because you have deprived this fiber intake. Therefore, you create those problems, behavior problems. Then supplementation of short chain fatty acid can reverse those alterations. We also demonstrated this is a receptor. This is through the GPR41 and 43. What about if we provide the beta glucan? Here's a chronic study. This is a control diet, make a nice nest. This is a high fat feed for long time, like the 15 weeks. Then they do not make the nest, do not organize this behavior. However, if you give them, then you give them beta glucan diet and start to make their nest again. This is a statistic quantification with more animals to prove the same phenomena. Exploratory behavior, high fat and fiber deficient diet, they do not explore to the new objects, but with the beta glucan, they will come back again. So in order to prove the gut microbiota plays a key role in terms of mediate the beta glucan induced those effects, we specifically using antibiotics to wipe out gut microbiota. Then you see here the beta glucan's effects no longer exist. In this case, you see the toxic material is started to increase, like your high fat deficient diet, unlike this beta glucan supplementation. Therefore, from here, we have demonstrated that the gut microbiome is really critical for our health, or in animal study at least. The behavior will be the same. Use antibiotics to wipe out bacteria, quite similar to fiber deficient diet. Same for other tests as well. Now here we try to demonstrate simply the gut microbiome. Here so we use 16S sequencing for all gut microbiome. Here to demonstrate the richness. So the control diet, and if you deficient fiber and high fat, the total number of bacteria will significantly reduce to half. Now you have this beta glucan can significantly reverse such deficits. In terms of the proportion from different species, so we have a lot of data, so we try to simplify this data to demonstrate the beta glucan's effect. Therefore, quite similar to the control. If you deprive the fiber, you make quite a different proportion in composition to the bacteria. Same for this one. So the beta glucan is quite important. Now, after we look at the gut microbiome, we look at the intestine, the wall. As this picture shows that this is the outside, this is your mucus. Then here is your villi. Then here you can see this is the wall of your and the wall at the very bottom. Here, this is really inside the gut, your cells. Then here, again, coming inside, the staining is for the mucus. It's quite thick. With a fiber deficient diet, it's very thin. And with the beta glucan started to reverse. This fluorescence image. Also, you look at this bacteria. It's quite far from the structure. Now with the deficient fiber deficient diet getting close, that can invade your gut. Toxic material can get in. With the high beta glucan diet, again started to form separation, which can protect your gut from bacteria, from toxic material. Now after that, we look at what happened inside the brain. Here's the picture to show the brain. Beta glucan diet supplementation suppresses microglia activation and inflammation in the hippocampus. At the very beginning of this talk, we talk about hippocampus is important for memory and learning. As you can see here in the hippocampus, this is the control. This is inflamed when you do not eat the fiber. This is fiber deficiency in the high-fat diet. The cells become inflamed. With the beta-glucan supplementation, then you can correct this inflammation in the mice model. The more importantly, we have shown that the immune cells. Now here is the standard for your immune cells in the brain, in the hippocampus. This is called microglia. Then we use another staining. It's called a PSD95. The PSD95 only exists in the neuron, the synapse. This is called a postsynaptic protein. So it belongs to the neuron when you form the communication. This is in the normal, and in the inflamed, like this group, high fat deficient diet, you can see the red coming into this green. This means that activated the immune cells started to engulf or swollen, or eat those post-synaptic protein. After they eat those synaptic membrane and protein, the neuron network start getting damaged. This form the basis for the cognitive deficits. Here's the evidence. When you have the high beta-glucan diet, this inflammation is significantly reduced. Not only that, when we look at the ultrastructure under the electron microscopy, we can see the beta-glucan improves the synaptic protein in the hippocampus of mice. Again, from the basis of beta-glucan can improve cognitive function. Here is your synapse. This is very dense. This is a gap. Here is your synaptic cleft. Here is the synaptic vesicle, presynaptic. Here is the postsynaptic. If you have the fiber deficient diet and high fat, as you can see, it's very thin on both sides. Then if you have the beta-glucan, you increase the postsynaptic density here. the synapse become normal, back to normal. So this is the evidence, the beta glucan under the electron microscopy when you look at the ultrastructure. We also measure the other proteins in terms of more detail what the protein play important role for learning and memory. Now from here we move on to the human studies. The slides was on the animal using the mice. Here's the human study. Then in the population across the whole world, the obesity, type diabetes is really very high prevalence. So what we have done was we talk to the industry about our research about the dietary fiber, and we extracted the beta glucan, make the product for the human trial. Now, first we use this product to feed the mice. We have demonstrated the mice into the gut can stimulate the production. It's called a PYY. The PYY can travel through the bloodstream to your hypothalamus and regulate the arcuate NPY, neuropeptide Y production to suppress the food intake. By using the human, this picture, it is when you eat the beta glucan diet, it can tell your gut to produce PYY. From there, this PYY can travel into your hypothalamus to the brain to tell the brain to suppress the food intake. In fact, you are not full yet, but this signal tells brain do not eat too much. This is the pathway we have demonstrated, published in the literature. This is the human study. We give the beta glucan diet similar to the animal study. You can see when you increase the beta glucan from a low, medium to high, and production this molecule PYY will increase, similar to the animal study. Although we cannot look at the hypothalamus of humans, but this is the blood. And also we look at the insulin response, PYY response, etc. From there, we have published serious papers about the human response in terms of high intake of beta glucan diet. Okay, thank you. Thank you for listening to this talk. I wish you have a great day.
Okay, thank you, Professor Huang, for that great presentation. Now we'd like to open the floor to the questions. Please feel free to ask the questions either by typing in the chat box or by unmuting yourself. So does anyone have any questions for Professor Huang?
Any question will be very welcome.
From my side, it's okay. Yuan Yi, I'm sorry. Hello, Prof. Sufeng.
Hello.
Yeah. Yeah, still interesting to talk about beta glucan and the effect of health. I just wonder, is there any specific dose of beta glucan that you recommend based on the research you have conducted? And what is your view on beta glucan intake and food rich in beta glucan? It means which one better? What do you think? Thank you.
From a chemistry point of view, we have studied the three main different types. One, this is they call it 131 four link come from grain, for example, from oat bran. This is the most significant effect from our study is to lower your LDL, which is a very convincing result, both from humans and experimental animal models, which is great. The mushroom 1316 also have some this effect, but mainly we found now is to modulate your immune system, particularly a very good effect on the monocytes. The third one is a single very short, just 1-3, just cut it very short. But that one has some effect, but not as strong as the others. In terms of oats, it's really great. It come from oat bran, not from whole oats. Whole oats is just too much carbohydrate there. Thank you, Deanne, for the question.
Okay, thank you, Prof. It's very nice presentation. Okay, thank you.
Thank you.
I think there's another question
Yeah.
from the Spreya in the chat box. He or she asked how many oats or maybe oat bran to consume to reach 5 grams per day.
That's a very nice question. From the product we make, it's about 22% in terms of the concentration of beta glucan. You have to special treat. Then in terms of that, you only need to eat something like a very small amount, like 15-20 grams a day will be sufficient in the morning. But normally, when you buy from other sources, they are before they getting treated is around 5 to 7%. So therefore, it's quite fair bit. Then normally you have to make really the soup to consume, then allow you to eat a bit more.
Okay, thank you, Professor Huang. I have another question, so because people, so every individuals have different conditions, like their gut microbiota or other factors, they are different. So do you think beta glucan supplement or dietary fiber supplement could be personalized, and how could that work in practice?
Yeah, the personalized medicine or personalized diet, it will be the future. It will be the future important research question. For now, we do not have the answer. But this year we have joined with Indonesia, led by Dian, Professor Dian, and also from Thailand and the Philippines, four countries. We submitted the government to solve this problem using artificial intelligence and a high-level mathematical calculation. So I hope we can answer this question in 3 years' time. Now we work up very hard trying to get this program working. That I also need to say thanks for the four countries' government to support our adventure. Thank you. Good question.
So does anyone have more questions? If no, so thank you very much, Professor Huang, and thanks to everyone for the excellent questions. Now I'd like to hand over to Afina, who will introduce the next speaker.
All right. Thank you, Yuan Yi. Thank you, Professor
Thank you,
Hu.
Prof. Huang. Thank you, Yuan.
It was a
Thank
great
you,
and
everyone.
insightful presentation and discussion also. And here I'm Alvina. Dear participants, I want to welcome to this session. So my name is Alvina, and I'm honored to serve you as the second moderator for this session. It is now my great honor to introduce our distinguished speaker, Associate Professor Wangkana Sinamong Srikamnong, PhD, from the Institute of Nutrition, Mahidol University, Thailand. So Professor Nadine, is a food chemist by training, and her work has significantly advanced fields of functional food development, bioactive compound optimization, and dietary strategies for metabolic health. She also earned PhD in food science and technology from the University of New South Wales, Australia, and complete her postdoctoral fellowship at Rutgers University in the United States. She has been actively involved in developing resistant starch-based functional foods, investigating their impact on gut microbiota and cardiometabolic markers. And also, Prof. Nadine serves on various scientific and safety committees and is a member of American Heart Association and the Asian Congress of Nutrition. Her recent projects include innovative applications of banana flour and fermented tea byproducts, and her multidisciplinary approaches are integrating with food science, microbiology, and clinical research. Today, Prof. Nadine will present an interesting topic on unripe banana powder as a resistant starch for satiety and glycemic regulation, innovation from Thailand. Hello, Prof. Nadine.
Hi, Alfina.
Hi, how are you today?
I'm good and very excited.
Very nice, perfect. Are you ready to present?
Yes, I'm ready.
All right, Prof. Nadine, the screen is yours.
Thank you. So first I'd like to share my screen. Okay. So I might need to switch on my video because my bandwidth is very low. So then I make sure it's not discrete. Can you see my screen?
Yes, I can
Yeah,
see.
so first, before I start, this morning there is an attack in Thailand. So I would like to mention about 1 minute that in memory of honoring the Thai life lost this morning, it was deep sorrow, respect that we pay tribute to the Thai individuals who tragically lost their life in the recent attack. So this devastating event had left an indelible marks on our collective consciousness, reminding us of the fragility of peace and the profound cause of violence. So I just like to move on that. So without further ado, I would like to start. The topics, as Avina has introduced, it's unripe banana powder as a resistant starch source for satiety and glycemic regulations, innovation from Thailand. So good afternoon, good evening, everyone. It's my honor to be here today among such a vibrant and inquisitive groups of future researcher and also scholar. So today I'd like to take you on a journey, not just into a biochemistry of starch, but also into a social, agricultural, and nutritional innovation rooted in one of Southeast Asia's most familiar fruits, which is the banana. So I would like to begin with posting a question. Can a fruit that is often discarded before ripening hold the key to managing metabolic disorder, such as diabetes and obesity? So, and our answer lies in the concept of resistant starch. Professor Huang have mentioned a lot about physiologies and also different cell chains in terms of neurobehaviorals in animals. But for my talk today, it's going to be an overview of the banana powder, our current progress, and also the future's plan that what we're going to do in terms of, as Professor Huang mentions, is the eAsia collaborative effort from 4 different countries. So first, Professor Huang has touched up on the metabolic syndromes. It is a cluster of related metabolic disorder comprising central obesity and also triglycerides and insulin resistance. So I'm not going to talk into detail because Professor Huang has covered it already. I'd like to draw your attention to the prevalence of metabolic syndromes in Southeast Asia and also Australia. So if you look at the map on the left side, you can see that there's a prevalence of metabolic syndrome disorder in Thailand and also in Indonesia is about 10 to 20%, while we found about 5 to 10% in the Philippines, a bit lower. But then there is a trend increasing of metabolic syndromes as well. In addition to that, there are also risk factors So there's various risk factors that can contribute to metabolic syndromes. It starts with genetic predispositions, epigenetics, and also physical inactivities like sedentaries. If you lie down on your sofa just now, probably it's better to get off and sit straight. And also sleep disruptions, also environmental and also ages. All of these also contributes to risk factors. But today we're going to draw your attention to a risk factor, which is diet. So it has been known that excess refined carbohydrates, saturated fats, and also fructose and low fibers, as Professor Huang mentions, a low micronutrient density could lead to metabolic syndromes. So therefore, we like to move on to the roles of diet. Diet play a central and also multifaceted roles in both of development and management of metabolic syndromes. Since metabolic syndrome is characterized by a cluster of interconnected conditions, again, Professor Wong have gone through that criteria of metabolic syndromes, and if you have those all 5 criteria, you will succeed to be metabolic syndromes. So the dietary patterns of individuals follows can also exacerbate or ameliorate these risk factors. These are the tables show the burden of metabolic syndromes and also behavioral risk factors among adult population in South and Southeast Asian countries. So the countries the information has are Bangladesh, Bhutan, and if you look at a column, it's hypertension, diabetes, total cholesterol, and red color indicating that there's more than 30% of the populations in the country faces a problem. If you here, central obesity is like most of the countries, they exist to 30%, and some of the countries they even have more than 2 or 3 risk factors. And then the table below show what could be the linkages of central obesity and hypertension. Insufficient fruits and vegetable consumption has found to related to the metabolic syndromes, and as you can see, or the country from Bangladesh to Vietnam, Timor-Leste, they consume insufficient fruit and vegetable consumption, and also their physical inactivities are more sedimentary as we expected. So there's more than 2 factors that linked to metabolic syndromes. For these slides, I like to show you that diets do play a crucial role, which is linked to metabolic syndrome or metabolic dysfunction. How about Southeast Asia compared to global status? So the first top is global. The different color indicates different metabolic syndrome, which is DM, non-fatty liver disease, and also hypertension and obesity. So at the global scales, for DM, female and male, they have about 19 to 17% that exposed or actually diagnosed to have a DM, while about 47 to 43% was obese. How about Southeast Asian region, which is where we located, and majority of them come from that regions. So for both female and male, as you can see that we actually exceed the average of a global status. It is not something that we should be proud of. So it actually should be something that we think about it. But if you look at the obesity, so we are a bit or not very different in terms of a global average. So this is actually alarming for us that Southeast Asian regions, we have to focus on DM and also try to reduce the incidence of non-communicable diseases and also metabolic syndrome. So what could be metabolic diseases and its contribute to in terms of economic loss or a global burden scales? So if you look at the slides over here, it's the globe pictures, and Delhi, which is stand for the number of healthy year lost due to disease, disability, or early death. One Delhi is actually equal one lost year of a healthy life. So this number actually indicate that if you been diagnosed or having a metabolic disorder, metabolic syndromes, you tend to actually lost a healthy life of your year. In addition to that, when you lose and you're not being a healthy person, it could lead to reduction of work efficiency and also cost economics in terms of a bill that pay for your hospitalized, and also the efficiency to work. DM, obesity, hypertension, fatty liver diseases, and also hypercholesterolemia, all of these contribute to a global burden. And if you look on the right side, there is the numbers of, sorry if it's too small, there is number of these incidents are tend to increase. It's steady, so there's no one single year that it's tend to drop. So we live in the world that actually the population is now facing most of metabolic syndromes, and then we need to do something about it. So precision nutrition and functional food could be an answer for these. So precision nutrition, as Professor Wong have touched up a bit on this, it is a scientific approach to nutrition that involves developing a comprehensive and dynamic dietary recommendation, which is based on the unique characteristic of individuals. Rather than rely on one size fits all, this model precision nutrition will recognize and address the complexity of factors influencing health and dietary needs. So if you look at the right side over here, there's intrinsic factors and also extrinsic factors that made of us as individuals. So therefore, in this project, we're trying to use precision nutrition and also develop functional food, which the approach, it would be individual data driven instead of the whole averaged populations. And as I mentioned, the different factors that we will consider. The goal of this precision nutrition is to maximize health, prevent and manage disease. Recommendation type, after we get the results, it would be dynamic, which means that it will constantly change and it was tailor-made to individual needs. Lastly, the technologies that we're going to use in this project, it will be omics in terms of metabolomics, ionomics, and also AI. We will also implement the wearable devices and data analytic. All of this will try to answer the difference and tailor-make healthy plan diet for individual needs. Usually every time when we develop functional food or functional ingredient, we also have to look at the market or the demand. If there's no demand, then probably there's no point of making it. So therefore, if we look at the functional food market in the US billion from 2019 and projections to 2032, you can see that the market of functional foods also increased in size in US billion. And the majors or big market are Asia Pacific, followed by North America. And if you look at the clinical nutrition of diabetes care market size from 2023 all the way 10 years from now, the projections also increase, which means that there's demand for the functional food. There's a market for these, and there's a clinical nutrition for diabetes, which means people's actually diets with DM, and they really need some functional food to be used in their diet. So what is resistant starch? I brag about we can use resistant starch in banana. So resistant starch is categorized into 5 types. For unripe banana, we focus on resistant starch type 2, which is naturally resistant due to its crystalline structures. It will pass through the gastrointestinal tract undigested and reach the colon, where it is fermented by gut microbiome bacteria into short-chain fatty acids, like butyrate, for example, which have known to have anti-inflammatories and also insulin sensitizing properties. So these transformations is the heart of why resistant starch type 2 is being explored as a nutrition interventions for type 2 diabetes and obesity. So for short chain fatty acids, as Professor Huang also looked into that from the fermented gut microbiome in the large column. There's benefits for intestinal epithelium cells. There are also benefits in terms of glucose metabolisms and also improved lipid metabolisms. So there is a transition from resistant starch all the way after it gets fermented and then produce short chain fatty acid and its benefits. This is the papers that we published like 5 or 6 years ago in our group. We studied the effect of ripening stage and cooking method available in Guai which is like one type of bananas, and we found that it's like different type of banana, they contain different resistant starch. So from stage 3 to 6, they have pretty high, it's about 20 to 30 grams per 100 grams of resistant starch, while stage 7 and 8, the number of resistant starch is lower. So these are preliminary data that we use to select the green banana to be used in the studies. Talking about clinical evidence and satiety and glycemic regulations, now let's shift to the empirical data. So dietary fiber has been known to have different on hormonal effect, intrinsic effect, and also colonic effect as well. So in a randomized crossover trial involved overweight adult, participants consume meals enriched with about 20 grams of unripe banana powder per day for 2 weeks, and the results were promising. It was found that postprandial glucose response decreased by 22%, and participants report enhanced satiety, which means that it was measured by VAS. So if you look at the y-axis over here, stands for VAS score, is a visual analog scale. It's a question that we asked the participants. Again, it's resistance starts with placebo. And if you look at the resistance starts, it's tend to enhance satiety, which lead to reduced caloric intake and also a subsequent meals. In the study, they also find that fasting insulin levels show a downward trend and suggest improving of insulin sensitivity. So furthermore, the UBP, which stands for unripe banana powder consumption, is related to modest but significant increase of butyrate productions of bacteria. So therefore, we would like to introduce an innovation from Thailand, which is unripe banana. So yes, why unripe bananas? In Thailand, we produce a lot of bananas in terms of metric tons per year. And we also have variety of banana, growing homes like growing kai, and also these what is growing namba, or the variety that we choose look like. And when it's ripe, it turns yellow. So Thailand is a good source or production of banana. So this is the reasons why we choose the banana. However, the reasons why we choose the banana is also that we want to value added the banana. Because in Thailand, we have a long-standing tradition of agricultural resourcefulness. Our project stems from the observation that about 40% of the banana harvested, particularly Gui Nam Wa, over here, varieties are often discarded. And due to the premature harvesting, sometimes you have to harvest it due to the natural disaster and also to the market rejection. So a lot of them actually go to waste. So this becoming the opportunity instead of waste the banana, we saw it as a resource. So our team going to develop a functional food ingredients, unripe banana powder, which is shelf-stable, shelf-ready, and capable of deliver bioactive benefits. Again, the information or preliminary data we choose was from our previous studies, and then we will focus on the stage 3 to 6 of the bananas. And if you look at nutrient compositions of the green bananas, in 100 grams, they have about 152 calories. 36 grams of carbohydrates. And if you compare different varieties of bananas, growing and white tend to have a higher resistance starch compositions of bananas. So therefore, again, this is the reasons why we choose growing and white for the studies. You might have a questions whether, but then like quinoa or green banana powder should have been studied for several years and has been conducted in different countries. So these are meta studies that they gather the informations or recent evidence of nutritional and lifestyle intervention strategy for metabolic syndromes. As you can see, the color indicates different countries of the study has been conducted in Indonesia, Malaysia, Thailand, and Vietnam. And the size of the bubble indicated the sample size. So in Thailand, there are 3 studies that use green banana. It was conducted in 2018, 2013, also 2013. So that's about 5, almost 6 years that the study has been conducted. and then they don't really focus on resistant SARS per se. So therefore, we thought that this study could be implemented. And also, our study will be different in terms of, as Professor Huang mentioned, we use more AI and machine learning to look at more personalized nutrition or personalized response to the individuals. Why is that? So I'm sorry if it's too small, but I don't want you to read it. There is the outcome of various studies that had subject the green bananas to different in terms of animal studies and also to human studies. Most of the study conclude that there is a benefit of green banana, but for example, these studies conducted by Silva et al. 2015 in Brazil, they found that when they give a green banana flowers to people with overweight women for 45 days, there is no change or no effects. And if you look at reviews on metadata, there also it's not really found that significance or some study does not found any benefit. So now we think about it could be there's actually the response from the green banana is individual. So therefore that the study is inconclusive. Again, so we thought that, okay, then let's look on different individuals to see as different individuals could respond to green bananas differently. So therefore, it's here come the project that we're going to do together. So come to our clinical research plan. So our plan that we're going to a clinical studies, we focus on satiety, glycemic index, insulin response, and also metabolic markers. The benefits of this study is that it's going to be comparative data that we will use unripe banana powder against other resistant SARS. So we know how each individual responds to different types of fiber differently from oats from Australia, as Professor Hong mentions, ripe bran from Professor Dian Bawijaya and Big Neighbory from Professor Lizo from Las Palmas, Philippines. And then once we have the data, we use AI and machine learning and data processing to be able to dig down deeper and understand how each individual responds to different sources of dietary fiber. After that, we also formulate into potentials incorporation into foods, beverages, and supplement. Well, it would be probably tedious for you need to eat banana flowers like 20 or 35 grams per day. Well, that could be something unpleasant to do, but again, we will incorporate that and formulate it into more pleasant and innovative products. So updated on our current project, that is eAsia, we submit human ethical application. Again, when you work with humans, it's indispensable that you need to apply for the ethical committees to make sure that you're not going to kill them and give something unpleasant to them. And these are the banana guanamois that we use. So we tested on spray drying. Why we use spray drying? Because we want to, usually spray drying is easy and also to upscale. So therefore we choose spray drying, and also we test for resistant starts as we vary different conditions and also look at the conditions that give us a higher resistance starch. What is the innovations bringing to these and value chains development? So we're not only going to focus on the health outcome per se, but we will focus on different stakeholders as well. So from farm to functional food, we would like to translate this finding and translate this project to improve agricultural surplus, which is unwanted bananas, to health innovations. And we also emphasize empowerment to locals. So we engage the farmer, which is around the university areas, and also SME and food technologists to work collectively together to supply bananas all the way to product development. And lastly, we look at in terms of sustainability. We don't want to, as I mentioned, just only focus on reductions of LDL and also to improve the health outcome, but we want it to be sustained. So therefore, we focus on waste valorizations and also upcycling unripe and non-marketable bananas. So all of these also contribute to our projects and also livelihood of the farmers, SMEs, and also food technologists in our areas as well. So if you look at the right side, farmer is going to supply the green banana to us, and then food technologists and researchers will work together to formulate the green banana flowers, formulate it into a drink, and we hope that we will utilize green banana resistant starch not only to eat it as a resistant starch, but also use it as a fat replacers, stabilizers, functional ingredients, textures improvement, or textures enhancer. So all these we hope that one green banana would help not only for in terms of health benefit, but also in terms of food textures, and food scientists, and come at the end we would have innovative products. And I would like to touch on a bit about our regional collaboration and also capacity building as well. So if you look at the posters, you've seen that these regional collaborative efforts is actually from 4 different countries. So I'm so grateful that I'm part of these. It was supported by INHSS Joint Research Programs. We have our same goal together, that we want to reduce metabolic syndromes through the increase in intakes of fibers, and it is a collaborative potential. So we will look at different sources of fibers, but then the population will be 4 countries. Isn't it interesting? And the good sides about the project is it's going to be multi-center research, that we will harmonize the protocols. So we use a similar protocols. And the population study, as I mentioned, is going to be a parallel studies. So Thai people are going to have an opportunity to test on oats and to see the response. And within this 4 country, we will also enabling the knowledge transfer between us as well. So we will learn a lot from Professor Lizo, Professor Dian, and Professor Huang. And lastly, we also have exchange in students and academics. It could be in forms of internship, course supervision, and training platform. So again, we don't left anybody behind. There, all of you can be able to contribute and also be part of these regional collaborative and capacity building effort. So I would like to give a conclusion and also future directions. So the key takeaway for today is mentions about the unripe banana powder benefits and the potentials of it to reduce or help improve the status of metabolic syndromes, and it could also create innovation values. I also like to call for collaborations. Well, there's a lot of things that we can do together in terms of joint grant applications, product developments, or even clinical trials. So if you're interested, I heard there are also some Malaysian participants over here. You can also reach out to Professor Dian if you're interested to be part of these. And lastly, vision for Southeast Asia with the help all work together from Australia as well. So we like to create a regional hubs for functional food innovation and also for metabolic health solutions together. So last, I'd like to acknowledge my research team and also the community farms, the Nakhon Pathom, that provides the banana for us, our clinical collaborators that we now recruiting them, and also for funding support from PMUB, and also to Thailand National Research Funding, and also our collaborators from Wollongong, University of Brawijaya, EHE, and also University of Los Baños. So thank you very much for your attention, and I'm now welcome your questions and your thought. Thank you very much.
All right, thank you very much, Prof. Nadine. Let's give a virtual applause to Professor Nadine. So it was a very insightful presentation on unripe banana powder as a resistant starch source, which is a brilliant innovation from Thailand that beautifully connects local agricultural potential with the global, facing the global challenge. I also truly appreciate how this work also contributes not only in advancement of functional nutrition and precision strategies, but also the real world impact, like Prof. Nadine involves farmers, SMEs, and also food technologists in the process. Now, we would like to open the floor for questions and discussion. We have one in the chat box from Mr. Nurfianto Kiar Pangindung. I will read it for Prof. Nadine. Question to Dr. Nadine. First is that banana farmers in Indonesia, particularly in East Java, typically harvest their bananas early due to high market demand and volatile selling prices. In the end, they cause calcium carbide like CaC2 to speed up the ripening of the fruit, which is sometimes also not liked by consumers. Therefore, what are the opportunities for processing these unripe bananas, like in your research, can be replicated in Indonesia and improving our farmer welfare? I think the first question first. Prof. Nadine, time is yours.
Thanks, Sofinas, and thanks for the questions. This is actually a real problem that you faced. So from our experience, we found that when you actually accelerate the ripening, let's say unnaturally, there could be an uneven of ripening of the banana. So in terms of replicating, I think you can also do this in like similar from what we did. However, before you actually replicate what we did, we probably have to analyze what are the nutrient composition and also resistant starch and also dietary fiber. Because we found that if you look at the slides that I show, different varieties also have a different resistant starch. So I would suggest that first look at the nutrients compositions and also resistant starch of the discarded or unmarketable banana first. And then if there is resistant starch or any additional compound, we can also work up on that. So in addition to that, when you want to develop unripe banana flowers or powder, it's not necessarily focus on dietary contents only. The banana could also have other bioactive compound that could use as the functional ingredients as well. So first, know what's your banana content, and after you know that, you can also develop it into different innovative product.
All right, thank you for the explanation, Prof. Nadine. I hope it answers for Mr. Nurfianto, or maybe Prof. Huang. Anything?
Yeah.
Yeah.
Hello, dear Nadian. How are you? Just wondered how the test feel like the unripe the banana powder.
It's like bland, it's not bitter.
Oh yeah.
Yeah, so it's
It's not
bland.
a sweet. It's not a bitter. It's pretty good, honey.
Yeah, so it's like bland, and you can mix it with in milk or even with like hot water.
Right. You can make a soup or something just to drink it.
Yeah, or even mix it with congee, so you can also mix this as well.
Okay, thank you. Very, very good. I will try some. Yeah.
Wow, that's great. Continuing to the next question from Mr. Nurfianto also. He also asked about commonly rural resident, elderly, and recently a trend among urban resident consume steamed fruits like bananas and tubers. What is the proper steaming process and its potential as a nutritional intervention for metabolic syndrome? Thank you.
Okay, so that's actually a very good question, because like we now in the era of not only recommended what food you should eat, but then like how you should eat it. I can give banana an example. So we in Thailand we consume banana. Our cooking methods are different. So we grill it, boil it, and also steam it. And if you look at resistant starch or even glucose, we find that if you grill it, glucose is actually increase the glucose content, which is not applicable. I mean, not recommended for people that they need to control glucose content. So therefore, we recommend that they could also boil them instead, because that we found that like when you boil the banana, the tannin would actually reach out from the banana peel. So if you boil it with the peel, and then we actually tested in our human subject, we found that like when you consume banana and tannin together, it actually maintain your postprandial. So that's an example of when you're talking about steaming, it depends on I would suggest that you steaming as the whole peel so that the tannin will be reached out into the banana pulp, so it will reduce your postprandial. So again, this is our study and the variety is different. So I could talk in terms of the sample that we test, but you can also test on the same test that we conducted. So, but from our study, the conclusion is we recommend that they steam it with the whole peel, like with the peel, and then like after you steam it for 10 to 15 minutes, and then you peel the banana and then you just eat the bananas itself. Again, same thing with boiling. So we found that by eating with those cooking methods and practices, postprandial is actually reduced compared to grill the banana. But also you have to make sure that in terms of tubers, like for example, potatoes, they have like alkaloid and also those toxins. So the cooking time and steaming method would be different from banana. So that would be, I think, something that we have to look on to make sure it's fully cooked, prevent the toxins just before we're actually talking about the increase of glucose or the increase of dietary fiber or resistant starch. Same thing with taros. If you steam it, because taros also have alkaloid and allergic compounds that could be have health adverse. So you have to make sure that you completely degraded them before you actually consume.
Thank you, Prof. Nadine. I hope it answers for Mr. Nurfianto. Continuing to the next question coming from Ms. Talita. What are the long-term implications of daily consumption of UBP as a resistant starch source and on gastrointestinal health, particularly in relation to fermentation-induced gas production, Prof. Nadine?
That's actually a very, very good question, and it has been our concern for a very long time. WHO recommend the fiber intakes about 25 to 30 grams per day per individuals. So we just want to make sure that you don't exceed that. Sometimes this is very good, we're going to eat it more. Well, everything has a certain effective dose. For water, you might think it's safe, but if you drink like 10 liters of water at one time, it's going to cause adverse health effects. Same thing with unripe bananas. The recommenders is usually about 20 not to 25 grams. And if you have internal bowel disorder or celiac disease, or you tend to have a bloating after consume high fiber. So again, this is the reasons why we want to look at precision nutrition and individual, because you actually could differently respond to the dietary fibers differently. So what I suggest would be that when you consume fibers from any sources, you also have you have to monitor yourself and the responses your body have. Your friends might be able to tolerate like 30 grams, but then for yourself, if you eat 10 grams and you feel like bloating or discomforts, I would suggest that you stop or reduce the consumptions of banana or even different sources of fiber. So to conclude, I think it would be that you have to monitor yourself and the response that you have for the different fiber consumption.
Thank you, Prof. Nadine. Actually, I also have tried the unripe banana flour. I roasted it and I mixed it with skimmed milk. It tastes quite good for me. I add 10 grams of UBP, and I think that's very nice. But we still need to know other individual has different tolerance of the unripe banana flour. Okay, continuing to Carl, Mr. Carl Joseph Estrada. There's a question from, there are two questions. The first one is about, could this innovation be adapted for other tropical fruits with similar starch profiles, Prof. Nadine?
When you talk about similar starch profile, you might want to look at what are the starch profile, because like for resistant starch itself, there's like 5 different types. So we use unripe banana because we focus on resistant starch type 2, which is naturally occurring. But if you talk about resistant type 3, which is from the heat processing or cooking condition, it could be different. And in terms of the natures of the food, even they have the same carbohydrates profile, let's say it's very unlikely, for example, even in the banana from our studies, we found that different stages of ripening, they also have different carbohydrate profiles. So there could be a potentials to implement, but at the end, you might have to validate. And also the method, also the processing technique, I can share with you our experience like using spray drying conditions. We use banana peel and also we tend to spray dry them. But if you use too much or too high temperatures in terms of technological feasibility, it will also clog in the nozzles of the spray drying. And also in terms of resistant starch, too high temperatures could also degrade the resistant starch and it's no longer poses that resistant starch activities. So again, I would not suggest that even when you talk about carbohydrates profile, you might have to match it into a more in-depth analysis on whether you talk about the soluble fiber, insoluble fiber, or monosaccharide, disaccharide, or different type or starch, because even you have a similar starch content, but then the food matrix could also influence and play the roles when you want to develop a product or perform a functional ingredient development.
Thank you, Prof. Nadine. Wow, it's been a very good discussion. And from Carl Joseph too, I would like to hold the second question because I think there are also like Miss Supriya, Mrs. Aziza, and also Miss Resi who are asking. But we also consider the time, so I would like to offer Prof. Nadine. Is that okay if other question will be through email? You answer it.
Yeah, sure, I can do that.
All right. One more last question from Mrs. Supriya is about how many calories of 20 grams of banana powder, and after being digested, how much will it change into sugar, Prof. Nadine?
So if you ask about 20 grams of, I don't have the figure with me right now, but I think it would be about 50 calories of 20 grams or even less. So that's approximately, but then I'm not sure I can get back with we did do a energies calculations. So I think it's about 50 or even less. And the second is about when you digested the glucose in there, right? So when we extracted there's only resistant starch. I think it's less than 1% of glucose, because when we develop functional powders of the unripe banana powder, we want to focus on only resistant starch only. So when there's a glucose on that, we tend to remove it. So it's actually vary between 1 to 2%, but then it is not a lot because, as I mentioned, we try to have only the starch, which is resistant starch. But then I can get back to you the exact number, and I don't have it with me in the moment, so sorry for that.
All right, Prof. Nadine, thank you for the explanation. I hope it answers for the questions. And I think the discussion and also presentation session for Prof. Nadine is very good and very nice. Let's give a virtual applause once again.
Thank you.
All right. Thank you, Prof. Nadine. I would like to continue, but then I want to read. There's a question on the first session for Prof. Huang. Hello, Prof. Huang. Yes. There's a question from Muhammad Nur. Mr. Muhammad asks about, based on finding from meta-analysis in humans and experimental studies in mice, how does dietary fiber play a role not only in lowering cholesterol, but also in potentially influencing cognitive function and behavior? Does this open up opportunities for nutritional approach as integrative therapy for both metabolic and neurological health? Thank you, Prof. Wang.
The answer in short is yes. In particular, in aging population, we do know there is dysbiosis in the gut in terms of microbiota. Therefore, to feed the proper prebiotics, increase the good bacteria population, producing the short chain fatty acid. In particular, like Nadine's mentioned, butyrate is very powerful. Actually, can get into the brain very easily through the bloodstream. To improve neural connectivity, which we have another paper Therefore, we want to do the study for the patients with MIC, mild cognitive impairment, trying to see this gut microbiota improvement with the prebiotics can help them in learning memory. And also in particular, you saw that the meta-analysis for the depression is very clear. There is improvement, reduce the depression by 23%. Therefore, cognitive function brain influence, the evidence is quite strong, but the clinical study need to be carried out more to prove that. Answer is yes.
All right, Prof. Huang, thank you for the explanation, and I hope it answers for Mr. Muhammad. Let's give a virtual applause to Prof. Huang.
Thank you.
And yeah, you're welcome, Prof. Huang. Next, I want to continue to the next session, which is the speaker 3, Prof. Dian Handayani. All right, it is now my pleasure to introduce our next speaker, Professor Dian Handayani, PhD, from the Department of Nutrition, Universitas Brawijaya, Indonesia. Professor Dian is a leading academic in clinical nutrition with a strong research background on the prevention and management of metabolic disorder through dietary interventions. She earned her PhD in Nutrition and Health Science from the University of Wollongong, Australia, and has been faculty member of Universitas Brawijaya since 2003, currently serving as a full professor and Dean of Faculty of Health Science, Universitas Brawijaya. Her research explores the potential of functional foods such as brown rice, virgin coconut oil, and moringa leaves to reduce inflammation, improve lipid profile, and support metabolic health. She also investigates the use of nutrition education tools, including mobile application, in community health intervention. Within the A-Asia Joint Program, Professor Dian leads the Indonesian research team in developing and evaluating rice bran-based dietary intervention for metabolic syndrome. Hello, Prof. Dian.
Hello, Alvina.
Hi, how
Hello,
are you
everyone.
today?
Okay, I'm good, thanks.
Okay, it's great that we are now in the same condition, same place, which is Wollongong, Australia.
Good now.
Okay.
Okay.
To Professor Dian, the screen is yours.
Good evening. Okay. Good afternoon, everyone. Firstly, thank you for the committee for having me to be a speaker as part of the Asia GRP webinar. So today I want to explain about the harnessing functional food for metabolic syndrome management, the role of brown rice and rice bran in Southeast Asia. My name is Dian Handayani. I'm professor in nutrition from Universitas Brawijaya, Indonesia. Little bit about my university. So our university located in Malang City in East Java. This is the two building belong to my faculty, and this is the building for the counselor of the Universitas Brawijaya. So in the map we can see here, so we located in Malang. It's around 800 kilometers from capital city Jakarta, Indonesia. Okay, I want to introduce about the problem of obesity. If we can see in here, WHO released in 2021 the area of obesity almost on whole in the whole the world, and then the global adult population 18 years and older become overweight and also obese, with the number 1.9 till 6 million become obese. The same situation with the Indonesian in my home country. We regularly conduct the health survey. We call it Indonesian Health Survey. We can see in here since 2021, 2023, and 2019, the prevalence of obesity getting increased. They never go down, and almost all of them obesity, overweight, and also the abdominal obesity getting increased. So basically, obesity it become the health problem in the world. Some researchers also say this has become the mother of the disease. If we talk about obesity, we can see in here the etiology of obesity is very. They can affected by environmental factor, genetic factor, but mostly, finally, affected by the imbalanced energy intake. So the energy intake that imbalance, which is food intake, is higher than energy expenditure, will promote the energy storage and become obesity. The energy expenditure can be decreased because of the lower of physical activity, low of thermogenesis, and also lower the metabolic rate, for example, in elderly people. And the genetic factor like dysmorphic syndrome, and then the mutation in some receptor like leptin, and also affect the obesity. And of course, we cannot ignore the environmental factor, the availability of food, sedentary lifestyle, hypothalamic injury, consumption of endocrine drug, and also endocrine disorder also promote obesity. The another concern about the obesity also study obesity and gut microbiota. So we can see in here, the individual with the normal weight should be balanced between vermiculite and bacteroidetes ratio, 1 divided into 1. But when they're getting obesity, so this proportion is changing because the bacteroidetes getting low, so vermiculite and bacteroidetes ratio getting increased until 20 divided into 1. So this is already studied by Panigrani, Fleschner, and also another college is since 2019 till now. So if we talk about obesity and insulin resistance, they really like causal each other. So when obesity, the adiposity increase, they will promote the abdominal secretion of pro-inflammatory mediator. So the another thing also, they promote abdominal adipokine secretion, increasing free fatty acid, and also impair glucose utilization. It will promote many things, health problem, and then the activation of inflammatory pathway will impair insulin signaling in adipose peripheral tissue and promote systemic insulin resistance on, and then we promote the hyperglycemia. So this is the connectivity between obesity and insulin resistance. If we talk about nutrition in the diet and etiology obesity, this is really close because study in animal model and also in human, it can show that obesity promoted by high fat sugar diet will change the metabolic syndrome in the animal model, also in the human. So we can see in here the consumption specific food like high carbohydrate, especially a simple carbohydrate, they can affect the composition of microbiota significantly. We can see in here from the top, high carbohydrate intake reveal increase the species of microbiota that have high capacity for fermentation, like Clostridium cluster, and then Lactose and also Clostridium Clostridioforme. So this is the kind of the microbiota that increase if we eat a high carbohydrate diet, especially in the what they call not complex. It's very high carbohydrate diet, but not complex carbohydrate diet. And then if we eat a high fat diet, what happens if we eat a high fat diet? So a high fat diet will promote the increasing a species of microbe that tolerant to the bile acid, for example, Alistipes, Bacteroides, and Bilophila. And then secretion of bile will increase because the fat consumption, and it will be promote the microbiota in the gut will increase. Unfortunately, some of the species like Bilophila Wordsworthia is correlate with the inflammation in the stomach. So high fat diet is not really good for our stomach and and also for the environment of the microbiota. And how about the protein consumption? And protein consumption also affect in the health of our gut. So in general, this picture show to us that the different of nutrient will affect of the health of our gut. So they will affect in our immune function, inflammation, and health in systemic. So that's why dietary approach play a vital role as a domain of the first strategy to treatment of obesity. So we must consider about the proportion of the macronutrient and why dietary approach is play vital role because this is being a daily habit. No one can left the food in the very long time. So that's why we're thinking about how dietary approach can maintain our health, and also dietary approach in some people relatively easy to do, and of course more physiologic and safe. Okay, so a little bit about metabolic syndrome. I just friendly reminder, this is cluster of interconnected metabolic abnormalities, including central obesity, dyslipidemia, hypertension, and impaired glucose metabolism. The risk factor collectively will increase likelihood of developing cardiovascular disease and type 2 diabetes mellitus. Over past decade, we can see that the prevalence of metabolic syndrome has escalated globally, with particularly concerning trend observed in Southeast Asia. So this region is undergoing rapid urbanized and lifestyle transformation, and then another contribution is unhealthy dietary patterns and decreasing of physical activity. So this is about the metabolic syndrome. Sorry. So dietary approach on metabolic syndrome, usually we think about how the intervention focus on dietary pattern, calorie intake, and specific nutrient consumption to improve metabolic profile and reduce the inflammation. So based on this reference, so we try to think about the high fiber diet as a key strategy to managing metabolic syndrome. The mechanism of high fiber diet in metabolic syndrome is very. The first one, they can diluting dietary energy density because the high volume for the dietary fiber from the raw food, and they can decrease the energy density. And then another process is also slowing nutrient absorption because the presence of fiber, and then suppressing appetite because the increasing of short chain fatty acid in many mechanisms I will show you later, and then modulating the gut microbiota composition. Okay, so if we talk about the dietary intervention, maybe we should remember there are many kind food categorized. So in this triangle picture, we can see this is the basic food. Basic food, it's mean the food that only fulfill the basic needs. Yeah. And then the second one is enriched or enhanced food. This is have physiological effect like positive nutritional equilibrium. So maybe because we want to increase one of the nutrient specific content, so we can choose the enriched or enhanced food. So this is to fulfill the positive nutritional equilibrium. And the third one is the functional food. This is unique. The functional food is still in food matrix, but this food is also have reduced risk of and enhance function, contribute to restore health. So that's why functional food is considered to be a part of the nutrition intervention. And then the last one is nutraceutical. Nutraceutical is really different because this is non-food matrix. This is have function as cure or heal from the health. And then we can see in here the functional food must be in food metrics and provide health benefits beyond basic nutrition, because functional food have specific nutrient or nutrient function, non-nutrient function that very beneficial to health, and then especially effective when consumed in whole food form, not pills or capsule or extracts thing. And then improve condition related to metabolic syndrome like obesity, insulin resistant, dyslipidemia, and also hypertension. And a whole food metric enhance the bioavailability, synergy, and long-term compliance. Okay, talking about the functional food, one that we can be considered as the functional food is rice. Research from Yi et al. In 2024, they are grouping the rice as a functional food with the classification like this one. Colored rice, yes, we can see the black rice, red rice, and purple rice that already modified from the from the rice, and then low gluten rice, and then also rice that's already high in micronutrient specific like zinc, selenium, vitamin C, and A and Fe. And how about in Indonesia? Indonesia also food position for the staple food is the rice. And the functional rice has emerged a promising dietary component due to content of bioactive compounds that offer health benefit beyond basic nutrition, including antioxidant, immune modulator, and metabolic regulator. So another thing considered to choose rice as the functional food based on the milling degree. So the milling degree optimally balance nutrient and texture and enhancing its function value. So based on study from Kwon, semi-wax rice, they call Milyang rice. This is really good because not too much process for milling. They only milling 9% or less than 10%. So then, my study is check about the function of brown rice. Basically, brown rice is white rice, but with the partially milling process. The whole grain of rice from which the germ and outer layer containing the bran have not been removed. This is why we call the brown rice, because because not too much milling process, the rice have the germ and outer layer. So the problem is this one become low acceptability, infrequently consumed due to coarse texture and less favorable taste, which can reduce the palatability and consumer preference. It's also limited awareness because public understand of the nutritional advantage of brown rice, such as high fiber, vitamin, mineral content, but remains limited. And then practical constraints, challenge such as longer cooking time. So because they want more smoother, so maybe keep longer the cooking time, and then little bit high in price and limited availability in local market. It's because they must be put in the specific packaging to avoid the odor and vapor because the fat from the germ or outer layer. So, but we know that brown rice is really high in nutrition. We try to identify the characteristic of macro and micronutrient bioactive component in the nation local brown rice. So this is study from our group. So we can see in here, if we compare between white rice and brown rice, for energy content, not too much different, and also the protein content, and then the carbohydrate, and also fat content. But if we talk about the dietary fiber, the brown rice have a higher non-soluble fiber when compared with the white rice. And the important thing is the very higher magnesium content. If we compare with the white rice is almost 30 times. 10 times, yeah. 230, and this one only 30, and also have good content of mangan. So that's why we consider brown rice possibly could be part of the functional food with the beneficial effect for health. And then the fiber of brown rice, dietary fiber in brown rice also have many mechanisms to maintain our health. For example, they increase gastric distension because the height of the fiber, so they will decrease the appetite and increase the satiety. Many studies also give information that they also increase the adipocyte lipolysis, increasing browning in white adipose tissue, and decrease the visceral fat mass, increasing in short-chain fatty acid, and then decreasing of colon pH, and then improve the microbiota composition. Many studies already reported for this one, but we also reveal the beneficial effect of the dietary of brown rice. This is also from a study reported that the fiber in the brown rice promote the increasing of short-chain fatty acid, and then promote the increasing of GPR41 or free fatty acid receptor 3. So the effect of the increasing of GPR41, they promote the increasing of PYY, GLP-1 secretion, decreasing appetite, increasing lactate production, and decreasing of lipogenesis. Another regulation and also affect in energy expenditure mechanism. Some study reported they increase the oxygen consumption, and then increase the adaptive thermogenesis, increase fat oxidation, and increase mitochondria function. Based on our previous study that brown rice also high in magnesium, some study reported that the decreasing of magnesium in our body is correlated with the situation of the type 2 diabetes mellitus and promote the complication in kidney and also in cardiovascular system. And also some study reported that in increasing waist circumference in obese person will decrease the serum of magnesium, mangan, K, vitamin A, and B9. So if we see the role of magnesium in insulin secretion in the left picture, we can see in here when the glucose enter to the beta cell pancreas by GLUT2 in the cell, glucose will be changed into glucose 3-phosphate, and then the enzyme, glucokinase enzyme, and promote the ATP and make the magnesium ATP complex. They will close the key ATP that can affect the depolarization membrane. The increasing of the polarization membrane will open the channel of calcium channel or L-type C2 channel. The polarization will open the type 2
L type C2 channel, and then the calcium will enter to the cell. So the increasing of the calcium level in the beta cell will promote the exocytosis granulation of insulin. So that's why the magnesium is really, really important. Level must be adequate in the body, so they can promote the exocytosis granula of insulin. And then in magnesium, in the second picture, magnesium also have the specific, the specific process. So we can see in here in the picture, insulin will be meet the receptor insulin in membrane target, and then receptor will activate the phosphorylation or IRS12, and then activate the PI3K, PDK1, and activate this pathway, and then it will be promote the insulin process to be metabolic insulin action as also the mitogenic effect. So all of them show that the magnesium level is really important. Okay. So this is the result from our study that so in obesity animal model, the magnesium and mangan and Ki level decrease if we compare among the rat model in normal and obese model. So this is also show the correlation between the magnesium with BMI. It means that the increasing of BMI will decrease the magnesium level. So this is really relevant with previous information that in the obesity, when a person have the insulin resistant, they will decrease the magnesium plasma level. So we try to make a study, compare the level of the white adipose tissue and body fat index and to animal model that give a different magnesium, different brown rice level. So we can see in here, the green bar show the 3-time consumption of rice, mimicking human in our country, 3-time eating a day with the staple food. So if the red consume brown rice higher, we can see the decreasing of white adipose tissue and also a body fat index. And also we can see in here, we check the Vermeerke test and bacteria test, the ratio of the microbiota also decrease when we give we replace the white rice into the brown rice. Okay, because limiting of time, this is information about the result, and then this is our last study about the effect of brown rice in adipose tissue. Again, they clearly decrease the visceral fat in totally in gram. The key one is the red that replace the food white rice into the brown rice. So if we compare with the high fat diet, red that get the high fat diet, they decrease significantly the visceral fat. Okay, this is also in adipose tissue area. And then this is also we compare a GLUT4 and GLUT12 expression in visceral adipose tissue. This is also from our student result. If we compare the high fat red positive group, and then the key one, this is red that give brown rice, the GLUT4 expression is increased, and also the GLUT12 expression is also increased. Many studies also conduct in rice bran, not only in brown rice. Rice bran, so we remove the rice, only study in the rice bran. This is study from 10 explain about the structure of rice bran and then the common use and how the rice bran contribute some environmental problem, even though it's really good in nutrition. Okay, so we can see in here rice bran bioactive compound. They have gamma oryzanol, tocopherol, tocotrienol, phenolic, and also GABA. This is all of them have a nutritional value that have the function for our health. Study from Lin explained that the nutritional value of the rice bran contain 10% protein, 90% fat, and 38% dietary fiber. So also contain a water-soluble fiber. So this is the refined rice bran on body composition. They are also good and white line. It's look like decreasing after consume the rice, refined rice bran, and also improve the rice bran and hematology analysis also show the significant progress when they consume the rice bran. Okay, also study from the defeated rice bran on metabolic parameter, significant change on defeated rice bran after 12 weeks, decreasing on systolic blood pressure, diastolic blood pressure, HbA1c, energy content, fat intake, and dietary fiber. There are many mechanisms on blood pressure and HbA1c reduction. Rice bran on metabolic parameter and also have beneficial effect on rice bran oil and rich in bioactive lipid. So there are many study about this one. Okay, so there are many parameter can be getting better, give the significant decrease in effect on waist circumference and fasting blood glucose when person get the supplementation with rice bran oil. So I think this is also promising study. Okay, I think that's all that I want to explain to you. So in conclusion, we can see in here the metabolic syndrome is rising rapidly in Southeast Asia due to the unhealthy dietary patterns. We already tried to reveal with the animal model and also in human study, the dietary pattern, decreasing of physical activity, then increasing stress, and etc. will implicate the pathogenesis of metabolic syndrome. And then the functional food like brown rice and rice bran are particularly affordable strategies for metabolic prevention and management. In my side, we still start with the brown rice, but the next study, we will start with the rice bran that also have a promising result like a previous study. And we will try to reveal the process, the supplementary of rice bran or consumption of rice bran, how it make metabolic syndrome getting better. So brown rice is rich in fiber, especially also rich in magnesium, and then they have effect like regulate gut microbiota, improve insulin sensitivity. So the important thing is brown rice high magnesium. Rice bran oil, refined or defeated rice bran also improves the nutrition status and also lower parameter for metabolic syndrome. Together, brown rice and rice bran is look like over synergetic effects, so still promising to be analysis for the effect for metabolic syndrome. Promoting brown rice and rice bran as daily staple support a culturally relevant and sustainable approach to combating metabolic syndrome in Southeast Asia. Okay, then, so as we look for practical, culturally relevant strategies to combat metabolic syndrome with the brown rice and rice bran, remind us that sometimes the most powerful solution are already as part of daily life, our daily lives. So rooted in tradition, by science, backed up by science, and ready to make a difference. Finally, I really thanks to all members that study with us regarding the brown rice, our PhD student, our master student, our bachelor student, and now we start with our new group with Prof. Sufong from Australia, with Prof. Lizel from Philippines, also Prof. Nadine from Thailand. We will study about our specific food from our each country, and then together to compare the result for a prevention of metabolic syndrome. Thank you everyone for be patient to watching my presentation. Hopefully it's useful for you all, and any discussion are welcome. So I back to the moderator. Thank you very much for the time.
All right. Thank you so much, Prof. Dian Handayani. Let's give a virtual applause for the great and insightful presentation on brown rice bran in managing metabolic syndrome, it's inspiring to see local staples are used in functional nutrition, which brown rice also shows strong evidence for improving gut health and insulin sensitivity, while rice bran also remains a promising area with ongoing research and great potential. So, Prof. Dian Handayani, there are 2 questions in this session. And continuing, the first one is from Edmar, Miss Edmar. Are there any specific preparation methods for brown rice that can enhance the bioavailability of magnesium and support its role in the insulin secretion pathway?
Okay, so I directly answer, Alvina. Okay, thank you
Yes.
very much for the question from Edmar. So basically, I never study about how specifically the preparation method for the brown rice that can enhance the bioavailability of magnesium. But I will try my best to answer your question. So based on the reference, the soaking process will promote the germination of the brown rice. The germination, it means grow the sprout from the brown rice. This process will good and potential for metabolic benefit because the process of germinated of brown rice will activate like endogenous enzyme like phytase that break down phytic acid that known as anti-nutrient that bind mineral such as magnesium, zinc, and iron. So possibly the specific preparation, the best thing is soaking brown rice firstly for around 12 until 24 hours before you cook this brown rice. However, based on our study, we do not the process this soaking of brown rice. We just use the fresh brown rice, give directly to the animal model, and also just cook usually for our preclinical study. And you see that the result is still quite good. So it means the magnesium in the brown rice still give the beneficial effect for metabolic syndrome, like promoting decreasing the blood glucose, and also decrease the HB1C. We already published this paper when we tried to replace the white rice into brown rice as a staple food. Hopefully this can answer from Edmar. Is this clear, Alvina?
Yes, Prof. Dian, very crystal clear for the answer. And the second question will be, is it true that cooling white rice can lower its glycemic index, thereby reducing its impact on blood sugar levels, Prof. Dian?
Yeah, so I think for this question, we back what the process happen when we refrigerate for 12 until 24 hour the rice. So some of the digestible start undergoes to retrogradation.
deforming resistant starch type 3, like RS3, which is this resist digestion in the small intestine and behave like fiber. So the answer is yes, but I'm not sure first people will like the very cool white rice. Mostly they try to keep warm to consume like that one. In my opinion, in my understanding, the important thing is we need to eat the variety of food. So not only rice, we can put vegetable, we can put we can choose the rice with the high fiber like a brown rice. So that's why it will be increase the fiber content. But the answer of question, is cooling cooked white rice reduce glycemic index? Yes, because with the process of refrigerated for 12 until 24 hours, the rice will be develop resistant starch type 3. So this is like a fiber. Yeah, but not really nice to eat the very cold rice, I think.
Thank you, Prof. Dian. So it's very important to maintain nutrition balance too. Yeah, Prof.
Yeah, and consume the various of the food is more better. Yeah.
Okay, very well noted, Prof. Dian. There's a third question coming from Miss Winda. What is the potential of promoting brown rice consumption as a long-term preventive strategy in population at high-risk diabetes, especially in regions where white rice consumption is predominant? Thank you, Prof.
Okay, sure. Thank you, Winda, for your question. How are you, Winda? Winda also our team in our research. So I think the promoting brown rice consumption really holds strong potential as long-term preventive strategy for population at high risk of diabetes, particularly in region where white rice is dietary staple. We already tried to pilot project to change the dietary staple from the white rice into brown rice, and the beneficial effect is quite good. They can decrease the HB1C and etc. And also we supported by many publication and also animal model research. Yes, the brown rice consumption will improve insulin sensitivity, reduce postprandial glucose spikes, and also promote healthier gut microbiota. This is really important. I think that's the answer. So encouraging a brown rice consumption can significantly contribute to diabetes prevention and improving diet quality and reducing glycemic burden, especially in rice-dependent regions. Okay, try it, Winda. Thank you.
Yes. All right, Prof. Dian. That's very insightful discussion. And also, there are from Miss Jaruan. She asked about how much rice bran should be consumed per day, Prof. Dian. Does rice bran contain magnesium?
Yeah, this is based on our pilot study, Jarwan, Miss Jarwan. So we give 3 times a day. The size is around 100 until 150 gram rice daily, 3 times. So it will be good for maintain the blood glucose and decrease the HB1C. In our previous study, we used the energy intake based on the specific energy intake, personal energy intake. So we give 3 times a day for breakfast, lunch, and dinner. Replace the staple food as an Indonesian habit with the white rice. We replace with the brown rice. Okay.
All right. That's nice, Prof.
Oh,
Dian, to
Prof.
know.
Sufeng also have a question for me.
Yes.
What level that industry will be interested to invest in? Oh, I don't know, Prof. I don't have any answer for this one. Actually, brown rice. The problem is brown rice because still have layer outer from the rice. They're not easy to be stored for the long time. This rice needs specific packaging, like vacuum packaging, to avoid the rancid odor because there are still many oil from the rice bran. So that's why it's a little bit expensive. Like the question from Mr. Edmar. Yes, you're correct. Brown rice little bit more expensive because they need specific treatment when they harvest and then put in the store with the vacuum packaging. So that's why, Prof, we consider to use only the the outer
Yeah.
of the rice. So we want to get the beneficial effect from the oat bran, rice bran. So let us see for the next research for that one.
Yeah, I think for academic researchers, if we want to have make a major impact to the community or society and across the countries, one way or another, we will have to bring the industry into
Yeah.
our program. I think maybe it's difficult. Maybe think about the future, including myself, how make our work translationable. Thank you,
Yeah.
Deanne.
Agree, Prof. Thank you so much for your insight.
Yeah.
Wow, very great discussion for today's session, and from Prof. Huang's session, Prof. Nadine, and also Prof. Dian. Very thank you, Prof. Dian. Good evening. And I think it's enough for the discussion
evening.
session
Thank
for Prof. Dian. Okay. And last but not the least, there will be a special speaker here, which will be moderated by Associate Professor Miss Anne Sayetano. Hello, Miss Anne.
Thank you very much, Miss
All right.
Elfina.
Yes, I will
Congratulations.
give it to you.
Thank you.
Okay.
So good afternoon, everyone. On behalf of the organizers, I would like to welcome you all to the last but very exciting session. Again, I am Anne Cayetano, your third moderator for today. So for this session, we are going to explore the nutrigenomics perspectives on the anti-obesity and lipid-lowering properties of Philippine indigenous berries. And as we know, and as what we have heard in the previous sessions, obesity and dyslipidemia remain a major public health challenge. And actually, the search for an effective and culturally relevant and naturally available solution is more important than ever. So our last speaker for this session will shed light on how the unique bioactive compounds in our very own indigenous berries in the Philippines can influence gene expression related to fat metabolism and lipid regulation. So without further ado, it is my great honor to introduce our distinguished speaker, my mentor, Professor Lizelle M. Atienza, a registered nutritionist dietitian serving as the current director and faculty member at the Institute of Human Nutrition and Food, College of Human Ecology, University of the Philippines, Los Baños. She's teaching advanced human nutrition, medical nutrition therapy, and nutritional biochemistry courses. She graduated cum laude with a degree of BS Nutrition in 2001 at UPLB and ranked second in the 2001 Nutritionist Dietitian Licensure Examination. She finished her MS Applied Nutrition minor in Biochemistry in 2008 and PhD in Human Nutrition minor in Food in 2016, also at UPLB. She conducted her PhD research at the School of Food Science and Nutrition in Washington State University during the period of 2014 to 2016. Her research area is nutritional biochemistry with focus on the role of Philippine indigenous crops on obesity and non-communicable diseases such as heart disease and diabetes mellitus. She also has several national and international publications and paper presentations. Actually, she earned 20 international publication awards, more than 50 paper and poster presentations at international and national conferences, and served as principal investigator or project and study leader in 10 research-funded projects. She also is actively involved in providing technical assistance to several government and non-government organizations on different aspects of human nutrition. And Professor Atienza also served as the lead proponent of the recently approved Master in Clinical Nutrition program of the IHNF. She also co-authored several manuals, including the Medical Nutrition Therapy 2 manuals in the university. And in 2021, she was awarded as UP Scientist 1 and is a recipient of the Outstanding Researcher and Outstanding Extension Personnel Award of the UP Las Bañas. Currently, again, she is our director, and she also serves as the editorial board member of the Journal of Nutritionist Dietitians of the Philippines and a member of the Phi Kappa Phi Honor Society and Philippine American Academy of Science and Engineering. Everyone, please join me in welcoming Professor Lizelle M. Matienza.
Hello, Ma'am Anne and everyone. Yeah, can I have like few minutes to fix my slides? Okay, I think I'm having a weak internet connection here. I'll just try to, yeah, I'm sorry. Okay, just a few more minutes. Oh, jokes. Okay.
I'm
Yeah.
sorry, ma'am. Ayan, yeah.
Okay. All right. So thank you so much once again, Ma'am Anne Cayetano, who is my colleague from the Institute of Human Nutrition and Food College of Human Ecology, University of the Philippines, Los Baños. So for this lecture, I'm going to focus on the following: the nutritional properties of Philippine berries in terms of their proximate composition, antioxidant vitamins A, C, and E. Also share with you their health promoting potentials in terms of their ability to counteract or fight obesity and dyslipidemia, as well as share with you some nutrigenomics perspectives from the findings of the anti-obesity and lipid-lowering properties of Philippine Bignay berries. So again, good afternoon to our participants from Thailand, Indonesia, Philippines, and Australia. So as you can see in the figure, 71% of deaths globally is because of non-communicable diseases, with cancer and diabetes as the leading causes of mortality. From the recently published literature or reports, and in terms of morbidity or the disease burden, it showed that cardiovascular diseases as the top one problem globally. And there are a lot of factors that can contribute to the increasing prevalence of NCDs, including CVDs. Most of these factors are modifiable, such as unhealthy diet and lifestyle behaviors, including lack of exercise, excessive alcohol drinking, smoking, and high level of stress. And these are all sources of what we call reactive oxygen species. High levels of reactive oxygen species, or ROS, can deplete the natural antioxidants in the body, resulting in a condition called oxidative stress, which creates a vicious cycle of oxidative stress and inflammation. Science has proven that excessive level of oxidative stress or reactive oxygen species is the underlying mechanism behind NCDs. And we should know that at physiologic levels, or not at high level, ROS is beneficial because it has an important role in the immune function. A lack of ROS in the immune system can actually impair an individual's ability to fight infection. But excessive ROS can damage the cell in the body and can contribute to NCDs. Evidences showed that obese people tend to have higher amounts of reactive oxygen species. These reactive oxygen species can stimulate inflammation in the fat cells or adipocytes by increasing the level of compound that stimulate inflammation, such as interleukins 1 and 6 and TNF-alpha. And they can also reduce the level of anti-inflammatory compounds like adiponectin. This is why obesity is considered as a state of chronic inflammation. The protective role of good nutrition against oxidative stress is already an established fact. A diet rich in antioxidant-rich foods such as fruits and vegetables can prevent the buildup of reactive that phytochemicals in plant foods can interact with our genes. They can downregulate or upregulate the expression of genes that control oxidative stress and inflammation. And as you can see in the figure, there are two major biological functions of antioxidants and how they can combat or defend the body from oxidative stress. These are their ability to regulate cell signaling pathways, wherein they can interact with the expression of genes and transcription factors, causing cell apoptosis or cell death and tumor suppression, modulation of redox reactions and inflammation. The other one is their ability to protect the biomolecules such as lipids, proteins, and nucleic acids from oxidative damage. They inhibit lipid peroxidation of LDL, inhibiting endothelial dysfunction and inflammation. There are plenty of bioactive compounds or natural substances in foods, particularly in plant foods. These are called phytochemicals. So phytochemicals have antioxidant and anti-inflammatory and immune-enhancing properties. Hence, it is important to diversify and add variety in our diet. The arrows show the interconnections of their functions and processes that extend up to the cellular and molecular level. As you can see, natural products and substances contain bioactive compounds, and these bioactive compounds are in circles, as you can see in the figure. They are connected to inflammation and oxidative stress regulation that influence the immune function or immune system. Also highlighted in the figure in red boxes are the not so healthy food items, which are considered inflammatory and promotive of oxidative stress. So why berries? Among all fruits, berries in particular are well studied as they contain the best dietary sources of natural substances with strong antioxidant properties. Examples are polyphenols such as flavonols, proanthocyanidins, elagitanins, phenolic acids, and anthocyanins that are responsible for the red, blue, or purple color in berries. A lot of work has been done in berry research. Most of them were conducted using native berries from other countries. In the US, I had the opportunity to serve as part of the research team as principal investigator that investigated the effect of wild raspberry extract on human cell called human umbilical vein endothelial cell or UVEC. These cells were made diabetic by adding high concentration of glucose to induce oxidative stress and inflammation, and then added with increasing doses of raspberry extracts. Results show that wild raspberry extracts were able to downregulate the expression of pro-inflammatory genes such as IL-6 or interleukin-6 and transcription factors like NF-kappa B. We also had an opportunity to work on a project using obese diabetic mice where we added 10% of freeze-dried berries specifically the wild raspberry, in mice feeds for 2 months, we observed that mice group supplemented with 10% freeze-dried berries had reduced levels of reactive oxygen species in the blood and significantly higher levels of antioxidant glutathione peroxidase in blood and liver. So for the Philippine indigenous berries, preliminary investigations have shown that they are abundant in various health-promoting and disease-preventing compounds. In fact, preliminary profiling of the phytochemicals in the 3 indigenous berries in the Philippines, namely Bignay, Duhat, Lipote, showed that they have plenty of bioactive compounds or phytochemicals in them. And the top 3 most common phytochemicals in these 3 berries are phenols, tannins, and flavonoids. When it comes to their antioxidant activity, this is just a snapshot of the results of the studies that we have conducted in the past together with our research team. This one is using the DPPH scavenging activity where we have identified the level of the antioxidant activity in these 3 native or indigenous berries, the Duhat, Lipote, and Bignay. And then we try to compare them with the antioxidant activity of other antioxidant-rich fruits based on the available data in the literature. And as you can see, we are proud to say and to share that our top 3, our Philippine indigenous berries, Duhat, Bignay, and Lipote, are the top 3 fruits in terms of antioxidant activity. So now let me share with you some interesting findings of one of our berry research projects conducted by our research team from the University of the Philippines, Los Baños. So the berry Pinoy research was led by Dr. Israel, our program leader, Dr. Estacio, my co-project leader, and our research staff. And for this specific project, it was Dr. Ira Villapando, our PhD mentee, was the one involved in this specific project. So let me share with you how the Bignay berry, the Philippine Bignay berry looks like. So as you can see, there are 3 sets here. The A and B are the unripe berries. The C and D are the half-ripe, and the E and F are the fully ripe. And there are 2 in each set. The first in the figure is the Bignay Kalabaw, and the second one is the Bignay Common. Bignay Kalabaw is also known as Big Bignay, while the Bignay Common is also known as Bignay Small. So the morphologically speaking, the main difference between the 2 is the size of the berry fruits, wherein the Bignay Kalabaw have or are bigger in size than the Bignay Common. So let me share with you some photos from our research. Okay, so we use the freeze-dried form of berries because freeze-drying is known to or is an established method to preserve the bioactive compounds in fruits, including berries. So we use the 2 mentioned varieties of Bignay, the Bignay Common or the Bignay Small, and the Bignay Kalabaw or the Bignay Big. And the processing of this Bignay from pulping was to freeze drying was conducted at the Institute of Food Science and Technology. And then the feed formulation was conducted at the Institute of Human Nutrition and Food at the University of the Philippines, Las Baños. And then for the in vivo efficacy study on Bignay berries, this was conducted at the College of Veterinary Medicine. What we have conducted in this study is the nutritional analysis in terms of their proximate composition, antioxidant vitamins A, C, and E determination, and the dietary fiber content and glycemic index measurement. For the in vivo efficacy, okay, so we had to acclimatize the Sprague Dolly rats from Taiwan for 2 weeks, wherein they're provided with commercial maintenance rodent pellets and distilled drinking water ad libitum. And then it was followed by 3 weeks induction of obesity, wherein the normal diet group was fed with regular diet imported from the US, while the high-fat diet group was provided with a high-fat diet, wherein 50% of the total calorie was from fat. And then after the 3 weeks induction, then they were randomly grouped into 3. So one group is for the negative control, the high-fat diet with cornstarch and distilled water without added bignai berries. The next 2 groups are the treatment groups, wherein one is high-fat diet added with freeze-dried bignai powder. And the bignai for that is the bignai common, and then the other group, the other treatment group is the high-fat diet plus freeze-dried bignai kalabaw powder at 10% level of supplementation, weight by weight. And then the normal group was given a maintenance rat diet and distilled water. Then daily, their food and water intake were measured. Then their body weight was measured weekly. And then every 2 weeks, the blood was collected for serum lipid measurement. And then the following parameters were measured. For oxidative stress, we use T-bars as a proxy indicator. Inflammation, we use TNF-alpha as a proxy indicator. We could have added more parameters or biomarkers, but due to limited resources, we just stick to this parameters. And then we had the measurement of body fats. So we measured the mesenteric fats, retroperitoneal fat, epididymal fat, and subcutaneous fat. Then we assessed the percent adiposity index. We also did a histopathological evaluation of the liver in terms of fat accumulation and inflammation. So for the results of the study, as you can see, basically, they did not differ significantly in terms of the carbohydrate, fat, protein, ash, and moisture content. But if we're going to look closely at the values, we can say that Bignay Kalabaw has higher moisture content, total ash, and crude protein, while Bignay Common, the small one, has higher crude fiber and the carbohydrate content. We also measure the glycemic index. So glycemic index is a rating system for foods containing carbohydrates. It indicates how quickly each food affects the blood glucose or blood sugar level when eaten on its own. So a value of less than or equal to 55 glycemic index score mean they are low GI foods or low glycemic foods, meaning that they are digested more slowly, causing a gradual rise in blood sugar. While a score of greater than or equal to 70 means they are high GI foods, okay, and it means that they are rapidly digested and can cause a quick spike in blood sugar. And as you can see in the results, both have low glycemic index score, which is around 30 to 40, which make them an ideal fruit substitute for better glucose control. In terms of dietary fiber, Bignay Kalabaw or the bigger Bignay variety has higher fiber or higher total dietary fiber, and most of them are from or insoluble dietary fiber. In terms of antioxidant vitamins, which basically provide not just or they not just act as essential nutrients, but also provide protection against free radicals or oxidative damage, it can be noted that Bignay Kalabaw or the big variety of Bignay has higher vitamin A and vitamin E contents than the Bignay common, while vitamin C was noted to be higher in Bignay common. So for the results of the in vivo study, the effect of the 10% Bignay supplementation showed that the group supplemented with Bignay common or the small variety has the highest feed intake. This is very interesting because we're very surprised of this finding, and it could be due to the higher or level of sweetness of this berry associated with its or influenced by its higher total soluble solid content, which was analyzed as part of the preliminary study. And another interesting finding is that the Bignay Kalabaw or the bigger Bignay variety, okay, when supplemented to high-fat diet group, had or showed the lowest feed intake. So it can be due to the high fiber content, which can cause early satiety or a feeling of fullness. For the effect on body weight, interestingly, the Bignay Kalabaw supplemented group had the least weight gain. And in terms of the adiposity index, which is an indicator of its ability to attenuate obesity, the Bignay Kalabaw supplemented group had significantly highest reduction in total body fats. In terms of the effects on liver steatosis or the deposition of fats in the liver as well as inflammation, it was noted that the Bignay Kalabaw had the lowest score, meaning it has the least amount of fat deposits and lower level of inflammation, which shows its potential role in fatty liver disease prevention and management. For the cholesterol lowering effect, the Bignay Kalabaw supplementation, 10% had reduced total cholesterol by 4.84%, which is basically higher than the reduction noted in Bignay common. For the triglyceride lowering effect, another interesting finding is that the Bignay Kalabaw supplemented group had significantly reduced blood triglyceride level by 37.32%. And for the HDL cholesterol enhancing effect, which is a type of lipoprotein known for its protective role to the heart, it was noted that Bignay Kalabaw supplemented group had significantly increased high density lipoprotein by 84.31%. And another interesting findings on Bignay Kalabaw supplementation is that it significantly reduced the level of T-bars, okay, which is an indicator of oxidative stress in the blood, okay, and a biomarker of oxidized LDL, which we know is an established risk factor of cardiovascular disease. Another interesting finding on the effect of Bignay supplementation on inflammation is that their ability to reduce the level of TNF-alpha. TNF-alpha is known as an inflammatory compound or biomarker. So as you can see in the figure, no, there's this almost similar reduction in the level of TNF-alpha in both Bignay common and Bignay Kalabaw supplemented groups. So for the summary of findings, what we can derive from the this studies that fruit variety matters. Not all fruits from the same type are the same in terms of health effects. And so as we have noted in the study findings, comparing the two cultivars, BK seems to have greater potential role to counteract obesity by reducing food intake and dyslipidemia by reducing oxidized LDL and inflammation. So this means that choosing the right variety of fruit, especially among indigenous berries, can make a big difference in how much they can support health. It also highlights the importance of studying local fruit varieties so we can understand and promote the best ones for nutrition and disease prevention. And if you're going to ask how much of the 10% supplementation in vivo is equivalent to human dose, then using the Regan-Shaw formula or a formula to convert the animal dose to human dose, it showed that daily consumption of 233 grams or 1.5 cup fresh bignay berries, particularly the Calabao variety, is associated with lowering of obesity biomarkers, dyslipidemia, and oxidative stress and inflammation, with, of course, limited to the biomarkers and parameters that we have included in the study. So from these important findings, here are some nutrigenomics perspectives that can guide the direction of research on Philippine indigenous berries and cardiovascular disease, especially in the Philippine setting. So one area to consider in the nutrigenomics research is the gene expression modulation. We have noted in many studies done abroad that berries grown in developed countries where there are very abundant research on these berries, that this is one mechanism on how berries can ameliorate or attenuate CVD risk factors. So the antioxidants and phytochemicals, including anthocyanins, flavonoids, and phenolic acids, may influence the expression of genes involved in oxidative stress, inflammation, and metabolism. And this is a very interesting topic to explore for our Philippine bignay berries and other indigenous berries. And another is the bioactive compounds in berries may modulate genes involved in endothelial function and lipid regulation, supporting cardiovascular health. Another area where nutrigenomics can be, where nutrigenomics can be explored is in the area of anti-inflammatory gene targets using the Philippine bignay berries and other Philippine indigenous berries. As shown in the preliminary findings, berries or the Philippine indigenous berries may have the potential as well to regulate pro-inflammatory genes such as TNF-alpha and interleukin-6, possibly reducing the risk of inflammatory diseases common in the Philippine population. We can also focus on identifying the antioxidant or validating the antioxidant pathway activation that can modulate or attenuate the CVD promoting mechanisms in the body. So compounds in native berries may activate transcription factors such as NRF2, promoting the expression of detoxifying antioxidant enzymes such as glutathione peroxidase and superoxide dismutase. So we can also consider in nutrigenomics research on Philippine indigenous berries the nutrigenetic variability in the Filipino population. So these gene variants may influence how Filipinos respond to certain foods, nutrients, or diet. And understanding them can help tailor health recommendation and support research in nutrigenomics and disease prevention. So as you can see here, the genetic variants common among Filipinos are the following. The transcriptor factor 7 like 2, these gene variants are associated with a higher risk of type 2 diabetes and may influence how the body produces and uses insulin. Another gene variant common among Filipinos is the fat mass and obesity associated genes. And changes in these genes are linked to higher body mass index and obesity. And it may affect appetite and metabolism. And the methylene tetrahydrofolate reductase gene variant that can affect how the body processes folate and homocysteine, potentially increasing the risk of cardiovascular problems. So because of these genetic differences, Filipinos may respond differently to these berries, and some genes common in Filipino may make them benefit more from berry nutrients or need different amounts or doses. So this is one thing that should be considered in the Philippine indigenous berries and nutrigenomics research. And lastly is the insights from the nutrigenomics can guide the formulation of functional foods using local berries to address gene-diet interactions in the context of Filipino health needs. So before I end, let me acknowledge the members of the Berry Pinoy. We call it Berry Pinoy. That's the group of researchers and professors from the University of the Philippines, Las Baños, including the student mentees. So we had a very good collaboration, a successful and meaningful one. And also, thank you to eAsia GRP and collaborators for allowing us to bring the Philippine indigenous berry research to the international stage. So special acknowledgement to my collaborators, Prof. Nadine, Prof. Dian, and Prof. Wang, and the rest of the members of the eAsia GRP. Thank you so much.
Thank you very much, Professor Liza. Let's give her a round of applause, please. Thank you very much po, Prof, and congratulations for that insightful presentation. Indeed, it's very exciting how our very own indigenous berries can play a role in combating obesity and dyslipidemia. So for questions, I think we have the first two questions from Sir Edmar Elcarte. So let me read it, ma'am. First is, how can we make indigenous wild berries more sustainable, accessible, and affordable, considering that they are endemic to certain parts of the Philippines and are only available seasonally? I think it's one of the challenges of the project, right, ma'am? And I think the second question is a little connected. So let me continue with that, ma'am. So the second question would be, are there alternative preparation methods for indigenous wild berries aside from consuming them fresh that would preserve their bioactive compounds and maintain their efficacy in reducing oxidative stress and inflammation?
Okay, thank you so much for the question, Sir Edmar. To answer your question, how to make berries more sustainable, accessible, and affordable. Yes, that's a challenge because these indigenous berries are seasonal. They're not always available and accessible. So one way to make them accessible at all season or available at all times is to develop them into functional food products. Our university, specifically at the Institute of Food Science and Technology, are active in the research of producing functional foods from berries, including juices and fermented products, and as well as converting them into optimize functional ingredients like powders that can be added as food ingredients. So for another question, are there alternative preparation? Yes, freeze drying served as the best method to preserve the bioactives in polyphenol-rich foods, including berries. So as well as blanching them to not so high level. The blanching temperature, I think, is around 60 or less, it makes the bioactive compounds, especially the polyphenols, more bioavailable.
Thank you very much, Prof. Lizelle. For the other question we have from Miss Alfina. So if bignay berries are consumed as other forms, such as an infused drink, is there any recommendation or evidences on how much we should consume daily to achieve its health
Yeah,
benefit,
thank you for
particularly for young or
thank you for the questions, Alfina. So yes, it's interesting to know how much dose would human dose would really result to lowering this metabolic parameters associated with cardiovascular health. One challenge here in the Philippine setting is the lack of clinical trials and nutrigenomics research in berries. So it will be very interesting to do this study so we can come up with an accurate amount or dose that would result in achieving the health benefits of berries, including its cardioprotective benefits. So these are interesting areas of research in berries where we need resources and collaborations.
Thank you, Prof. Lizelle. So what we have right now would be the fresh, the recommended amount of consumption, safe amount for
Yes,
consumption for
yes.
fresh berries.
Yes, but let me just add, but based on the preclinical trial that we have conducted and as presented to you, so the equivalent freeze-dried berry that can be formulated or can be diluted with water to form or to formulate a juice is around 40 grams. 40 grams freeze-dried berries. Or it can be eaten raw, getting the same set of nutrients at amount of at 1.5 cup. Yeah, as I mentioned in my slide, as I indicated in my slide.
Thank you, Prof.
1.5 cup fresh berries or 40 grams freeze-dried berries daily. But it needs more validation through human clinical trials and nutrigenomics research.
Thank you po, Prof. Lizelle. For the next question from Nerfianto Giar Pangidung. So what is your response regarding nutrigenomics through genetic engineering approaches, such as the genetically engineered tomatoes that are rich in GABA that may help lower blood pressure and promote relaxation?
Yes, that's a high level of research already, and that's something that we'd like to work on in the future. Right now, we are not yet into studying this kind of food items, the genetically engineered ones, because our focus now is more on the indigenous species, the indigenous crops in the Philippines. Because these indigenous crops are native to us, and it can help meet the diet variety recommendation, as well as relatively more economically accessible for Filipinos.
Thank you, Prof. Lizelle. I think there are a lot of questions because they are very interested on your topic. So is it okay if we limit the questions to the last three? So for the first one, we have from Talitha Alyadiva. So based on your research, are there any negative effects or concerns related to the consumption of bignay berries, particularly in the context of dietary management for metabolic syndrome?
Thank you for the question, Talita. Before we conducted the preclinical trial, we have conducted toxicity studies, both acute and subchronic, wherein Ma'am Ann Cayetano, our moderator today, served as one of the principal investigator. And so far, so good because these berries are safe for consumption, even on a long-term basis, based on the findings of our studies. And these findings and these manuscripts or studies are already published and can be accessible online.
Okay, thank you po, Ma'am Lizelle. And then second to the last, what are the recommended ways to consume bignay berries without compromising their fiber content?
Yes, there's no other way but to eat them fresh as far as I know. Okay, we can eat them fresh or we can we can freeze dry them without removing the skin. Yes, we can freeze dry the berries as well, so we can consume as a whole fruit without removing the skin. And yeah, eat them fresh is one of the best way to consume or not to remove the skin.
Thank you po, Prof. Lizelle. So for the last question, for the interest of time, I hope everyone's okay. So this is our last question from Ma'am Eloisa Villaraza, previous president of the NDAP organization. So congratulations, Dr. Lizelle. I would like to ask the possibility of food and nutrient drug interactions in some patients who have comorbidities already and is taking antihypertensive drugs or lipid-lowering drugs.
Yes, so thank you so much for that insights and as well as in a question. Actually, we have not yet explored the interaction of the berry or in the Philippine indigenous berry consumption with medications. So it's still best to consult the doctors regarding the possible interactions. But again, this is something that is very interesting to research on in the future. Thank you so much, ma'am.
Thank you very much for answering the questions, Professor Lizelle. I think that's our last question for today. If you have other questions, please feel free to email the organizing committee or Professor Lizelle. Do you have other things that you want to add, Ma'am Lizelle?
So I just want to say thank you again. Thank you so much to eAsia JRP and my collaborators, to our team, Ma'am Ann, because Ma'am Ann is also part of that. We're excited to know the effects of Philippine indigenous berries on metabolic syndrome and the exploration of using AI through the mentorship of Dr. Wang. So we hope to get very good findings and something that we can share with our with Filipinos and as well as at the international level.
Thank you very much, Professor. And I think that ends this session of the program. Again, thank you very much for all our speakers for sharing your expertise with us today, specifically on highlighting the richness of our own local food biodiversity as our potential ally in fighting different chronic diseases. So we hope that everyone got inspired for further research and collaboration. And that's it. Thank you. And back to our host, Ms. Rihanna.
Okay, thank you, Ms. Anne. And thank you so much for all the moderators and the speakers. And we have now come to the end of today's webinar. On behalf of the organizing committee, I would like to express our sincere appreciation to all our distinguished speakers for their insightful and impactful presentations, and to all of you, our participants, and for your active engagement and presence throughout the sessions. And let us now take a moment for a group photo. Kindly turn on your cameras if you are able. Our committee will take a screenshot in 3, 2, and 1. Okay, once more. 3, 2, and 1. Maybe once more again. 3, 2, and 1. Okay, thank you. Before we end today's agenda, may I kindly remind all participants to fill out the attendance form through the link provided in the Zoom chat. And your presence is highly appreciated and will be officially recorded through this form, and the link will remain active until end of the season. Thank you. We hope this webinar has inspired new ideas and strengthened our regional collaboration in addressing metabolic syndrome through functional food innovation and precision nutrition. Stay safe and healthy, and we look forward to seeing you at our future sessions. This concludes our program. Have a pleasant evening. Thank you.
Thank you,
Thank you. Thank
everyone.
you.
Thank you.
Thank you.
Okay.
Thank
you.
you
Thank
very
you.
much.
Thank you.